Yep.
Okay.
Yeah. Yeah, no problem. What do you need this one? Test, test, test.
I was like, no, you're good. I'm sorry.
Okay. All right.
You can turn it off until you're ready.
Great.
Okay.
Hey everyone, thanks for at CA Veracode, and I'm here to talk about open source and the risks of open source development, the benefits of it, and how you can actually manage the risk so that you can safely achieve the benefits of open source. I've been at Veracode prior to our acquisition by CA for almost 10 years, and I am going to be your tour guide on this session this afternoon. So what we're going to talk through today is a little bit of an understanding of the open source ecosystem, and in particular, the Java open source ecosystem will be our focus this afternoon. We're going to talk about why developers use open source and what the business benefit is that they're ultimately delivering through the use of open source libraries and applications. I'm going to answer the question, how is open source free? What is it free as in? I'm going to talk a little bit more specifically about Java, and we're going to answer the question about how does software age, and if I don't answer that, remind me and we'll get to it. We're going to talk about some data from, from this report, which you have a flyer for on your desk, the State of Software Security, where we've assessed over 400,000 applications for security findings, including looking at the open source components that were in them, to draw some understandings about how developers use open source code and why open source risk is becoming more prevalent. And last but not least, we're going to talk about ways that you can practically start to get your arms around open source risk in the applications that your organization is building. So let's get started. So when I started my career as a developer 20-something years ago, the practice of software development was a little different than the way it is today, and in particular there was a much smaller understanding of any of the concepts that we think about with open source today. And I think the biggest change that's happened in the industry is that there's been a shift from, kind of either free-range artisanal software development where you're responsible for building everything that the application does, through the use of commercial components, and in the case of where I was when I started, 4GL languages where the platform provided a lot of the low-level functionality for you, to the world we are today, where the advent of things like standardized ways of managing dependencies and the growth of open source ethos and infrastructure has allowed us to treat open source much more like an assembly line model with interchangeable parts than that free range, lovingly handcrafted model that it used to be. And the end effect of all of that change is that if you look at modern software applications, they're assembled, they're not just made. So yes, there is proprietary code in all applications that enterprises build, but it's also wrapped with a lot of open source and commercial components that provide access to standard reusable functionality. Just as a show of hands, how many folks would imagine that the ratio of open source to proprietary code in Java applications today, typical enterprise Java application, is as high as 50-50? Anyone think it's that high? Who thinks it's higher? Higher is right. So we see anywhere from 70% open source to 90% open source in the enterprise applications that we assess based on the size of the libraries that are being analyzed compared with the size of the commercial code that's involved. So 5 to 10% commercial proprietary code that your development teams are writing, and then it's as though there were one room in the house that you were continuing to paint and improve and add furniture to, and every other door in the house was closed and you weren't dusting in there, right? So it's a really interesting realization when you think about all of the value that open source code provides to modern developers. And then I think that it poses a question, or at least it does for me. If I'm in an enterprise and I'm responsible for developing or securing applications, do I know what that ratio looks like for my applications? Do I even know what open source components I'm using in my applications? How would I figure that out? And we'll come back and talk about that as we talk about how to practically get your arms around this issue. This is not a talk that's designed to beat on open source. There are sound reasons that developers are consuming open source code, and it's all about the trade-off between quality. This is my favorite sign in Seattle's Pike Place Market, and I like it because it reminds me that what developers are incented on is this triangle between shipping on time, shipping the functionality that they're trying to get into the marketplace, and making sure that it's done with a high level of quality. Most developers I know have a lot of pride. They do not want things that they've done coming back with bugs and the bugs being attached to their names because they screwed something up. In a lot of build culture, software development cultures, if you break the build, you get a little trophy on your desk to shame you for being the guy that broke the build, right? So developers are motivated by quality, and the great thing about open source code is, especially if it's an actively maintained project, you have good quality functionality that's easy to adopt, that is typically maintained, and it does what you need it to do so that you can focus on that special business logic that's going to help your business do business, right? And there's been a lot of stuff that's happened over the past 20 or so years, 30 years really, to get us to where we are today that open source is that prevalent. Everything from the GNU project, where Richard Stallman first said code is free like speech, not like beer. And then marrying that up with the Linux kernel to get to the stage where we have free and open source operating systems. The advent of Google suddenly means that instead of going down to the Barnes & Noble and picking up a textbook that's that thick on software development, you're typing a question into the search bar and oftentimes finding a code snippet or a library that's open source that does what you want it to do, right? And then the advent of SourceForge and GitHub, respectively, providing ways for people to discover open source projects, collaborate on them, and get insight into how actively they're maintained. And last but not least, there's Maven, and we'll talk a little bit more in the next section about what that provides to the open source community. So let's actually go there. So when we're thinking about specifically the Java open source ecosystem, which is one of the healthiest open source environments and communities around, Maven is kind of at the center of a lot of what goes on. There are other component repositories. There are other standard ways of invoking dependencies, but Maven is certainly among the most successful. And if you look at the numbers that are right on the homepage of the Maven community repositories, which I pulled out on the slide, you start to understand why. Maven provides a standard way of indexing not just components, but other whole repositories. And there are 250 different open source repositories that you can get to through the central Maven repository site. The most popular is Maven Central, and that's the one we'll focus on. There are 2.2 million indexed Java artifacts or libraries, jar files, that are recorded in the Maven ecosystem. That's a lot of software. And it's not just a stagnant pool. There were over 500,000 Java artifacts added in 2016. We're on track to beat that for 2017. And the other great thing that Maven gives you is a view of how the open source projects relate to each other. Java open source is great because it's a series of building blocks, and one component gets used by others. So if you look at unit testing, which is a key ingredient of modern software development that's important before you go and do Agile or DevOps development, the most popular Java framework for doing unit testing is JUnit. There are 63,000 other open source projects that depend on JUnit, to say nothing of all the commercial and enterprise software that it's been wrapped into. So Maven is great. It gives you that visibility of how all this stuff relates together. Okay, so far we've been talking about the benefits of open source development, the scale of it, why it is that so much open source is in so many enterprise applications. Let's talk about the flip side. And before we make the transition, I want to point out a key stat that's on the front page of the little brochure that you've got in front of you, which is that all software is insecure. 70% of every application that Veracode looked at in the State of Software Security had at least one vulnerability that's in the OWASP top 10 list of most heinous web issues, right? And an even higher percentage had at least one vulnerability, period. And that's true of open source software as well. And some of those bugs are security bugs, right? So the flip side of Maven is the National Vulnerability Database. Like the Maven repository, this is a repository. It's a repository for known, disclosed vulnerabilities in software, whether that's commercial or open source. It has 95,000 as of October, when we were looking at these numbers, vulnerabilities or common vulnerability enumerations, CVEs, that had been indexed. There were 35,000 of those, or over a third, that were high, or 2,600 that were critical, meaning that if somebody exploited them, the attacker could own everything about the system, all of the data, could totally compromise availability of the software that vulnerability was found in. And just as Maven is not a stagnant pool, it's constantly growing and being updated, so is the National Vulnerability Database. There were 11,000 CVEs that were published in 2017 through October, and that number is not holding still. So we have a great, vibrant open source ecosystem. We have data that shows all software is vulnerable, and we have a constantly growing pool of disclosed vulnerabilities, including in open source software. This is why we're starting to worry about open source code and open source components, given that most Java applications are majority or better composed of open source libraries. This was a theoretical problem for a few years, and then came Heartbleed, which was a kind of a wake-up call for a lot of people. This was a vulnerability in a commonly used library, OpenSSL, that was present at systems levels in deployed applications, and that applications depended on to provide access to functionality around secure communication, encryption, and other things like that. And an attacker could steal data through systems that were deployed with the vulnerable version of OpenSSL, including patient health records in the case of community health. And so this was really the wake-up call, both for defenders who now were aware that not only was this a theoretical vulnerability, it was also actively being exploited. And also, I think this drew the attention of the attackers, who said, why should I bother finding point vulnerabilities in individual websites when I can find a way to compromise an open source component that's probably in 30 or 40,000 deployed applications out there and get a much higher bang for my buck? Okay? So, looked at at through another lens, another set of statistics, Forrester's survey data shows that 80% of developers are using open source in deployed applications. I would argue the other 20% just don't know whether they are or not. 46 Java components, Java open source components on average in enterprise Java applications. 44% of those applications have potential critical vulnerabilities in them from the open source components that they include. Okay, so that's the threat model, but if that's the case, surely developers are aware of this problem and are updating their components when a new vulnerability is announced, right? I mean, that's what happens, doesn't it? So the answer, it turns out, is not so much. So let's take a look at a couple of points of data from the State of Software Security study that we did that kind of really show what developers do about data about open source vulnerability. And it also illustrates something about why this is so much of a problem. Just as a methodology note, my TV colors are a little off there, but the way that we've gotten this data is in the context of doing the 400,000 application assessments that we based this study on. We had customers performing static analysis to find weaknesses in the proprietary code. At the same time, we were running those applications through a component analysis that helped to figure out what was actually in their software, and then we were matching it up with the vulnerability data to kind of give them that picture of all of the vulnerabilities in their application. And if you're interested in seeing that part of the software in action, the demo stations over there can give you a view into it. When we looked at all the data, we at first thought that we had made a mistake because the top component on the list was something that nobody had ever heard of, something called AOPalliance.jar. We could understand how libraries for HTTP clients and logging and other things like that had gotten on our top 10 list, but this first one was a head scratcher. So we went and looked it up. That's aspect-oriented programming. It's a way that Java developers can do things like model view controller paradigms, things like reflection, and it turns out to be a fundamental building block in very popular web development frameworks like Struts and Spring and other things. So learning number one from the data, sometimes you have a component in your software or in a lot of pieces of your software that you don't know about, that your developers didn't choose, but that is along for the ride because of something they did choose. The second thing that we learned was we looked at the most vulnerable components that were in the data set, and we saw that there were a lot of different vulnerabilities there, and what was interesting about them was, for the most part, the vulnerabilities that were on the list were years old, not a few months, so that maybe the developers would get around to patching the issues. Years old. Some of the vulnerabilities on the list were 8 years old and had been patched for 8 years and had safe versions available for 8 years. The one on the top, Commons Collections, was implicated in a type of vulnerability called Java deserialization. I can happily talk to you about that at another time. I'm not sure we have time to dig into the technical particulars, but another one of those vulnerabilities that would allow an attacker to take over a system. And that was disclosed in December 2015. And when we first did this study last year for open source components, that was at the top of our list then as well. It's still at the top of our list a year later, despite the fact that the vulnerability was patched a week and a half after it was discovered by the Apache team. Okay. And when you look at this longitudinally, there's no rhyme or reason in terms of customers being on safe versions of code to the left, unsafe versions of code to the right. And when you look at it year over year, as in the case of Commons Collections, the good news was that we saw this one bar here at 10.4%. A lot of customers actually adopted the patched version of this library, but just as many didn't. In fact, the unsafe version of this library is in a slightly higher share of applications this year than it was last year. So what's going on? I mean, the hypothesis really is that on the one hand, you have developers who may never look at the libraries that they bring into their applications once they bring them in and validate that they're working. To use our house metaphor earlier, they close the door to that room and they never go back in again. The other thing is, bear in mind that lesson we learned from AOPalliance.jar. And let's take a look at what, through the Maven repository, we know that Apache Commons Collections is used by. It's used directly by about 1,200 projects, but some of those as this scrolls through, were very popular, like validator logic from Apache Bean Utils, Apache Commons Configuration, SonarQube's plugin API, Hadoop Core, Hadoop Client, Hibernate, Velocity. So the bottom line is that if you are only aware of the open source frameworks that your developers are explicitly choosing, you don't know the whole story. A lot of those are going to depend on other open source components that have their own vulnerability history, their own challenges, and in a lot of cases, the developers are not even aware that they're there, so they're not reaching back and patching them. So what do we do about this, right? How do we start to get our arms around this problem to allow developers to achieve the business benefits of consuming open source, shipping higher quality code that has more functionality faster, but allow them to do so safely? So I'm going to propose that there's a couple of different practical things that you can start to do today to get your arms around that risk. And then I'm going to close with one thought about a slightly bigger step that a lot of organizations can think about taking as well. So when I say policy is first, I do not mean close the door and make sure that nobody else tailgates you when you go into the building. I mean, that's a kind of security policy. But what I'm talking about here is, what threshold of comfort do you have for deployed applications with known vulnerabilities in the open source? Not every vulnerability is created equal. Some may allow a total compromise, but others may be much less risky. And so do you want the development teams to chase every known vulnerability? If you're just starting to get your arms around this problem, maybe not. Maybe you want to start with the most severe ones. But our recommendation is set a policy standard and make sure that your developers understand it so that you're not negotiating with every development team what level of patch you need to fix. That way lies escalations, email trails, hurried meetings about why you're not letting me release, because I have an outdated component. Get it in policy. It makes your life much simpler. Second, inventory. So a couple of times we've talked about the fact that it's not necessarily apparent even to the development teams what libraries are in the things that they're using. But if you are using simple tools, certainly there's something that's part of the Veracode offering that runs as a built-in integral part of our static analysis that will give you this data. There are also, if you're just getting started and you're not doing anything else, use an open source tool to start building an inventory and an idea of what it is that's in your applications. It's a lot better than not doing it at all. The benefit of using a tool like Veracodes is you get all the data in one place. You can track, over time as new things get published, you know what applications have those components that the new vulnerability has been published in. But you have to have the inventory. You have to know where your risk is. Third, just as with other aspects of application security, the cure lies in the developers. It's in their power. They need to be empowered to address these issues. And that means that they have to know that open source risk is a problem. Developer education is key here, just as it is for addressing problems in the proprietary code that the team is writing. And we know through the data that we see in the SOS report that if you give developers the knowledge that they need to comprehend the problem and to fix it, they fix it. We know that with structured e-learning, you get fix rates improvements of 20%. We know that if you get on-the-job coaching where they're actually looking at the results of a test, they can get even higher remediation rates because it's contextual to the applications that they're in. But make sure that your developers have the understanding of the problem and that they can really know that the open source is a risk and what they can do in upgrading components to get after that problem. From a practical perspective, the last thing is making sure that the testing that you do is integrated. You can do a one-time baseline, and that's better than not doing anything at all, but you're much better off if you're continually updating that baseline every time the development team changes their code, because if they incorporate a new library, you want to make sure that you know about it, and you know that from the start it's not something that's risky. There are simple ways to do that. There are lots of tools available that you can plug right into your build pipeline in Jenkins, in Continuous Delivery Director, that will inventory the applications as they're going through. Again, if you're doing it through the CA Veracode platform, the identification of open source components is happening at the same time that you're doing the static analysis, so it's one integration point, very straightforward. And last but not least, you know, as we're closing the point, and there's a couple of observations that I would want to make about how you think about this problem. I said at the beginning that open source software has been argued about whether it's free as in beer or free as in speech. I would argue that for the purposes of this discussion, open source is actually free like a puppy. As a developer, you're bringing it into your application, but you can't abandon it. You have to continue to nurture that and make sure that you're keeping an active eye on it. It's not something that you set and forget. Look, and the reason is, as we've seen with the data, software doesn't age like wine. It ages more like milk. And I don't know about you, but I don't want software code that nobody in my team has looked at, but that security researchers and hackers surely have, uncovering vulnerabilities, to stay for years in my application without my knowledge, right? But the last thing that I want to recommend is that we've been talking at the first part of this presentation about the benefits that open source brings to software development teams and to organizations, right? But I would suggest that you think about that benefit through a business lens, and you think about the balance sheet that that development team is building by the incorporation of that open source functionality. In the classic balance sheet, you have assets on one side, you have liabilities on the other, and as I bring open source code into my project, it's surely an asset because it's allowing me to move faster. But there's a carrying cost, and you have to stay current with it to make sure that you're not too far away from the latest released version, because when that suddenly discovered vulnerability comes across your radar screen and you realize that it's in a component that's been in your software for 8 years, and that's when the last time was that you took a patch for that software, you may actually find yourself in a position where you're so far behind in tech debt on that component that you have to declare bankruptcy. You have to take a radical approach to relieve yourself of your dependency on that component because you can't afford to rewrite the application to deal with the changed behavior of the latest version of the component. You've got to pay down that debt more frequently over time. So that's my advice to the development teams as well as to the security teams about getting after this problem. We're almost out of time. These are quick talks. I would suggest that if you're interested in this problem of application security, that there are a couple of other really interesting talks to check out. I, in particular, want to recommend Don't Overreact and Shifting Security to the Left. Those will be great talks to come to. If you do want to see Vericode's solutions in action, we're at the demo stations over in the security area. And I just want to thank everybody for coming and their attention, and I'll take whatever questions you have now. Well, thanks very much, guys.